Well, I have a few things to talk about, ask about, share, but if anyone else wants to start first, I can. Sujit, you want me to go now, or you want to go?
I could go. I mean, so our okay. So the highlight of my um, life after I moved to this project was this open source Bengali Albert language model. So the training has finished, um, and they are doing really well on NER tests. So the model itself is basically an Albert model. So it's trained on mask language modeling and sentence order prediction. And the way they were testing it out is applying it against an NER benchmark. And it seems to have an F1 of 95.6 and accuracy of 97.5 against that benchmark. So that's really good. The loss came down from around 11 to 2 over the period of a week of training, distributed. At its peak, they had like 50, 50 notebooks running simultaneously. It petered out towards the end, but average was about 20, 25-ish people doing it simultaneously. Right. So, that was good. I will write a blog post this weekend on it. So I have more details with charts and graphs and everything. So that is nice. Also, what was the other thing I was doing? Oh, so I was looking at neural search methods. And Yuri, thank you for the link to the Hofstadter lectures. I've been, I did the last one and the one which started on neural methods. So I've been kind of, spot picking them and, cherry picking them kind of. They are good, a lot of information. So, trying to absorb some of it. I tried working with Pyserini, which is a Python interface to Lucene. So Anserini is the basic idea, right? Where it's basically like a benchmark thing for, running different search benchmarks, right? It's a toolkit. And Pyserini is a Python interface to Anserini. So basically right now, the Pyserini thing works flawlessly with your own index. So they have a simple script to upload your index from JSON files. And you can do simple searches on that. I was kind of working, based on the last Hofstadter lecture. So it said Pyserini was also able to do dense and hybrid searches. So that is what really excited me to try it out. But dense and hybrid doesn't work for your own indexes because you'll have to build an encoder that encodes documents into vectors and creates a PICE index. That bit I figured out yesterday in conversations with the developers of the Pyserini project. And the other bit is that your input query has to be encoded into this vector, right? So you need some kind of model that takes the query and encodes it into the vector. And obviously you want to store all your document vectors, ahead of time so that you don't have to do it all over again. And they're using FICE for the approximate nearest neighbor matching. So
can you spell that library? What was
Pyserini? Let me put it in chat. There, I think I got it correct. Yes.
Yeah. No. Okay. And how is that different from Vespa? We call it vector search, right?
Yes, Vespa is a full-blown hybrid database or indexing platform, right? So it can do TF-IDF, BM25, as well as HNSW approximate nearest neighbor type of search, right? So it provides a platform to do this. Pyserini is basically a Python interface to Lucene. Their main objective is to run different kinds of benchmarks. So they have a bunch of downloadable indexes and, basically you can say get pre-trained, and it will pull all the stuff down, and then you can run your benchmarks against those indexes. But I kind of figured that I might want to use it for testing different neural search strategies for my own platform, which is an adaptation of BERT Serene. So the retrieval piece, currently I have a Solr setup, like I'm creating a Solr index, and I built a Solr plugin for Answerini that looked like Answerini, right? So it basically does query rewriting and re-ranking and so forth when it does the retrieval. So that bit is now being supplied by Answerini using their own core stuff, right? So Pyserini is basically just a light wrapper that calls the Java Answerini jar, right? Which has all this stuff built in. And it connects to the Lucene database. It also connects to, it offers dense searching using FICE as the AND platform, right? So yeah, so that's basically it. So, doing that. And then I had a slightly...
Another question about that is,
sure.
It's kind of a basic question. When we talked about vector search, sort of when we talk about Vespa, we sort of talk, I understand it's a platform, but we talk about vector search. But now, what's the difference between that and neural search? Or are they pretty much the same thing?
Yes and no. Vector search, neural search uses vector search, but vector search is not neural search, right? So neural search is a bunch of techniques where, to generate the vectors that you would use for vector search, right? So originally, the naive approach that I have also done is basically, create document vectors using a third-party language model, where you say, okay, it encodes the quirks of the language based, the vectors encode the quirks of the language, and therefore they're kind of proxies for a good search. When you do cosine similarity or whatever, it's a good proxy for actual search ranking. But lately, but so far what has happened is that none of these approaches, these naive approaches, could beat BM25. So lately, it has become like more of a contrastive learning approach, where you have, you take the query and the document, and you train a model to recognize queries which go, which should return a document versus which should not return a document, right? Relevant versus non-relevant, right? So you basically teach a model to predict that sort of thing. And then you use that model to do your vector search, right? So or more correctly, you use it as almost like how you use word2vec, right, as a pretext kind of thing. So now you have this trained model which can tell the difference between query and documents. You take the weights of this model and use it to create an embedding for the vector and an embedding for the query, and then you compare the two using vector search.
Yeah, it sounds like it's not really, but it's a little analogous to a task-specific layer or whatever. But basically, rather than just having the underlying embeddings you're actually training a model, which is a form of embedding somehow that is specific to search.
Yes.
So is it kind of like a search layer on a model stack?
Well, ideally, you should be able to use. Well, it predicts difference, right, or similarity, right? It's basically a model that predicts similarity, and you still use vectors from your pre-built index and vectors created from your query to compare with it, and that's where you would use normal vector search as well, right? So search, neural search would use vector search as a technique or as a tool in its pipeline, basically.
Okay, that sounds good.
And the third thing I've been doing is kind of a side thing.
Can I?
Yeah, go for it.
So you said you trained this model on your search to documents, and then basically, so after that you had your document vectors. So after that you can compare, instead of comparing search to document vectors, you can sort of transform documents into the search space and basically run a document through the network, and then is that what you?
Well, it's basically like you figure out some kind of model, a trained model, right? You train a model,
Yeah.
and then you pass your document through the model to get a document embedding, and you pass your query through the model to get a query embedding, and then you do vector search of the the query vector against the document vectors.
Oh, okay. I was thinking that your documents are already vectors because you might retrain them.
Yes. So that was my approach earlier, where I would use Cybert or some kind of BERT thing, where I would basically pass in all the sentences and then create a mean pool of the document and store it as my document vector, right? However,
But now you're doing it direct. Yeah, go ahead.
So what we found, that experiment was like a failure, right? So we found that none of our approaches, even the ones that are trained on biomedical text and so forth, like Cybert is, BioBert actually worked worse, but Cybert was the best among that. But even then, it could not beat the numbers for BM25, like a plain Linux, a plain Lucene search. And after I finished that experiment, this was about, I think, 1.5 years ago. We basically shelved the project, saying that we can't go any further right now. We have to wait for the rest of, or basically research to come up with some new ideas which we can try, right? But shortly after that, people demonstrated that if you had a Siamese type of network, which where you trained queries or trained documents and queries together to predict relevance or non-relevance, then you got better results. Since then, actually, this is also in Hofstadter's neural models lecture. They basically came out with ideas where you basically train. So initial approaches were basically just passing the query and the document text together and predicting whether it is relevant versus non-relevant, right? So basically training a model to do that. The next step was like basically doing Siamese networks with contrastive learning. So you pass in, you take these two or a set of shared weights where you send in a query and you get the embedding, and you send in the document, you get the embedding, and you try to update the weights in this in the shared weights block so that the difference between these two vectors is minimized, right, if they are relevant, and maximized if they are not. And then it went to triplet loss and so forth, and now they have something called Colbert, where it's actually they're using a shared transformer model, one for the query, one for the document. And then they're using another head on top, which is trying to learn how to predict the two. So these, I think in this case, the two towers are unchanged. It's only the top which is changed or something like that. But I cannot, I may be wrong there. So that's, yeah, okay. And the stuff that I had is basically like BERT Serini, where the backend, so the front end was basically all the squad models where you are given a passage and it can predict, and a question and it can answer. Whereas the backend was basically a Lucene index where you send in the query and pick up the candidates for using as the passage for question answering. So that was my original setup. And then I changed the setup to use these BERT vectors, right? So different kinds of vectors. And that was the failure I was talking about. So, this is one step ahead. So basically, that is what I got all excited about and tried by Serini for. Yeah.
Okay, now I think this is like a third time you are telling us about this project, but it sounds, I think it sounds different every time. So like I don't recognize if it's the same project.
Yeah, it's evolving a little bit every time. So. Yeah.
But the whole point, the whole point of it is to beat BM25, beat what you guys have in place now for standard search.
Yes.
Okay.
I have it might be elementary question, or we can like talk about it later. But so this is like I'm new to search itself, but So there's what I don't understand is kind of this whole relationship, right? There's a Lucene. What's the relationship between Lucene, Solr, and Elasticsearch?
So Lucene is the base platform. It's a search library. Solr is a platform, in early days, all Solr was a web interface over Lucene, so that you could have your index anywhere and you wrap it up in a web service, and you could query the index over the web, right? So that was all it was, but later on it morphed into a more of a, it got tighter integration and so forth. It had a nice console, and it basically did a lot of things. Elasticsearch went on the same idea that it had a web interface, but it focused a lot on distributed indexing, right? So you could now take your index and put it on multiple machines. And they had, I think it was called either Gossip or some other protocol. So Elasticsearch basically had a totally different protocol. So Solr also went distributed. Solr used Zookeeper, where you had like a master controller and different slaves, whereas Elasticsearch went on a total, flat, no master kind of deal, right? Decentralized, distributed kind of approach. I think that's the main difference, and they went after different markets. Elasticsearch went after the analytics market, so they said, you don't have to use Lucene for text. You can use Lucene for anything, like tabular data as well, and we'll provide interfaces to help you do different kinds of grouping and aggregation. Whereas Solr kind of concentrated on the text or more traditional markets, and so that was their main, two different. They aimed at two different markets, but then later on, both started eating into each other's territory. So now both of them are equally good on both sides.
But underneath it all, we're just talking Lucene. I mean, it's a Lucene stack.
Yes.
Is all three of those. And one other observation. This might be incorrect, Suji, but it seems like Elasticsearch rose with the cloud. It was more a cloud native play.
Yeah, could be that too. Yeah.
Yeah. Does that make sense, Yuri? They're just all built on the central core engine is Lucene Java. It's Java, right? And it's Lucene.
It's interesting. I learned like we use Elasticsearch, but only the Kibana part of it. But for search we use Solr. So like I didn't know why we would,
What is the Kibana part of Elasticsearch?
I think it's analytics front end, right?
Yeah, it's more geared towards tabular data and as you said, running queries. So you can actually all our logs are there, so you can actually like see what's going on.
Yeah. So it's exactly what you just said, CG. I mean, that's the analytics product built on top of of Elasticsearch using capability.
Yeah, and it's a good product. I mean, so for a long time, I think it's still true. Elasticsearch doesn't have its own console. They use Kibana for their, all interactions with the thing over the web, on a browser, right? Kibana is your main front end, whereas with Solr, you have your own built-in console.
Yeah.
Okay.
I mean, Lucene's the dominant open source search engine, right? That's all this grew out of. So.
Yeah, I think it's the most popular. There are others. So there's Terrier, but it never made, outside academics, it never actually did much. Also, there was Fast, which is now Vespa. But
and in a sense, there was Amazon. I mean, there was AltaVista. So I think of Lucene as the incarnation of AltaVista in the open source world, sort of.
So Pyserny is sort of like independent path to Lucene, right?
Which one?
The one that you mentioned, the Pyserny.
Fast?
No. The project I joined,
Answering. Yes. Yeah. Okay. Yeah, Answering is basically a platform to do Lucene-based platform to do benchmarks. Like, so initially it started like you can do Trek benchmarks. It had scripts, right? where they had all the indexes sitting somewhere on Amazon, and they had these shell scripts that will allow you to run benchmarks and report all the metrics. Kind of so if you were to wanted to go and do a different benchmark on something new, all you had to do was modify the little pieces that you cared about. The rest of the infrastructure was just available. You should run it, right? You created your new index, you made the tweaks, whatever in your search algorithm, and then you ran this thing, and it gives you back the numbers. So that was its basic idea, but now they've kind of morphed. So I came to Answerini from when I looked at the Bertolini paper, where they basically put the Answerini backend and a question answering front end, squad based. So that's what I basically replicated, except that the backend was all Lucene in case of Answerini. So I created a Solar thing, and because I had to create a platform, right? So which people could look at, not just CLI scripts. So that's why I did, and I know Solar best. I started with Lucene, but I don't use Lucene anymore much. So, most of the thing I've done since then have been Solar. So I created a Solar index with my data, and I wrote a custom plugin that mimicked Answerini. I tried to do it, just including the jar and kind of making calls into them, but the Answerini thing wasn't equipped to deal with that. That's when I actually contacted the Answerini project. What's his name? His GitHub is lintool, so I forget his name anyway. So I contacted them and said, can you open these up for me, right? So I can use them. Then they kind of went back and forth, and it never happened. So I basically looked at their code and wrote it, replicated it into my plugin. But now they have Pyserini, which is nice. So I'm going to throw away my plugin and use this instead. Also, it potentially offers support for dense and hybrid search. So that's good. We'll see.
Thank you.
Oh, and the third one I was doing, I rediscovered a use for, or I rediscovered projector.tensorflow.org, and I found a use for it. Visually displaying document embeddings. So what I did was I took the Cord 19 Spectre embeddings, which are basically document embeddings, and I tried to visualize them on projector. So it gives you a pretty nice thing. Although, it has, so I have like about 200,000 unique documents in Cord 19. It will only allow me to push in 10,000. So I had to sample from there. So, but it was, you can still see a little bit of clusters like respiratory disease and this and that. So, it was fun.
What was the tool?
Projector.tensorflow.org. Hang on, I'll put it in.
Oh, TensorFlow, okay.
Yeah, so one of our networks is based on TensorFlow, and my lead is using it, and he loves it. He because it's actually useful. Like he actually can see our embeddings really. Like if he changes something, he can see if embeddings get closer to each other visually.
Yeah.
So.
Embedding projector, there it is. Okay. Well, sort of in the spirit of some of that work, I have a general question. So I've done, I'm sure I've mentioned this before, I've done some similarity stuff using LSI, and I did it with a couple different things, but one thing I did it with was a bunch of LinkedIn profiles. I don't remember how many I had, 100,000 or whatever it was. But the point is we have prospects that we make available to our customers in our tool, and people who are interested in particular technologies. And what I want to do is do a recommender based on that person. So and I've done that using Similarity with LSI. But I've done it with Gensum. I used some VMs. It was messy. It was difficult. It was hard to manage. the training and so forth. So, but I think I might over the next couple of months sort of try to move in that direction again of doing prospect. Here's a person, give me similar people, right? Based on LinkedIn profiles. So we talked about all sorts of stuff like Vespa and vector search and neural search and all kinds of similarity stuff. So I guess I'm not so much, I mean, part of it is, sorry about that. Part of it is kind of a state-of-the-art question, but really it's about what's the easiest, what's a fairly easy, stable, scalable way to go at this problem? Rather than just me and, what would you guys recommend if you had to attack that problem?
Do you have access to LinkedIn data?
Well, yeah.
Okay.
Mm-hmm.
Is it in graph format or is it in, what format is it in?
It's text, but it's tabbed. It's like I have the sections delineated, so it's a
TSV.
Yeah, it's well, yeah, exactly. I mean, I put it in Parquet as always, right? But yeah. CSV.
Do you see graph based, like Neo4j kind of thing? Do you think that might help? Looking, seeing how many hops there are and so forth.
I'm not sure how I'd attack that. I mean, it's I don't know how I do that from the data I have, right? I'd have to have I'm not sure it really has the network of people. Like, so each record, so you're saying each record would need to have like people who are following or friends with them or something, or?
Yeah, I mean, if you can get some information out of that, it depends on what signal, I mean, if there is available signal in that, right? Say you find an article that I'm the author of, and then you look me up on the LinkedIn graph and you see, okay, who are the people who are connected to me? And that will be a terrible signal. But
so you're saying just find people who are connected to the person and see if that.
And what kind of things they are writing, right?
So you sort of filter the connections.
Yes.
Well, a lot of this is going to be really sparse. So a lot of these people aren't going to write anything. Oh, but they really, almost most of the data for sure, right, at LinkedIn is it's just people having their job history.
Right.
And the tags and stuff. So you really can't depend on someone writing. Now, if they've written a bunch of stuff and they're in the same topical area, that could be a pretty good, more of a thought leader kind of person. And that could be a higher value prospect.
What's the goal?
What's the goal? The goal is to get more people to possibly call and contact and sell your software to. So you could think of it two ways. You could, so you're looking at a screen, right, that says Bank of America has been these 10 people look like they have a project a buying project because they've been reading about search engines, right? So it looks like they're about to buy some search engine technology or do something with it, because these 10 people at Bank of America have been reading TechTarget's content, okay, in that area of search. So I'm a marketer or a salesperson, and I see that and I go, well, I want to sell into Bank of America because I represent Vespa or whatever. I'm trying to sell some search engine technology. And so, I have some leads, within Bank of America. Maybe I want to find other people within Bank of America that are similar, or maybe I want to just find other prospects at other companies that have similar titles. I don't know, something like that. But they're basically the same, the person who is similar technology-wise and experience-wise.
Vector search might be good. I mean, that's more, across multiple features, except that you don't have much control over the features. Yeah, so this, if you're looking in general, or you could do something that one of my colleagues did recently for a different kind of problem. So he used vector search, and then he filtered along the dimensions he cares about. right? So he goes in and says, okay, I want to find nearest neighbors. So it may be like, 10 nearest neighbors or 20 nearest neighbors. And then of these 20, who are the ones, which are the ones that are of this kind of semantic type? So he was looking for, procedures, or actually diseases for a procedure, right? And so he goes into this embedding thing where you have all our different entities, and he finds the nearest neighbors. So first he finds of these nearest neighbors, which of these are procedures, and which of these are procedures that are manually marked as, which of these are diseases given a procedure, and of these diseases, which of these are marked, manually in our taxonomy with ages from disease to drug with high age weights, right? So that gives him like a very small number of diseases that are uniquely used or used heavily for this procedure. For which, the diseases for which this procedure is heavily used. Yeah.
Okay.
So this is a similar approach, right? I mean, you could go look at your Bank of America employee who's been reading your stuff, find similar, and then you say, okay, I want to target only Bank of America, only California, something like that. And then you could filter those nearest neighbors by these criteria, and you have a much smaller list of people to contact.
Yeah. Rather than just, of course, that makes sense. Rather than just taking the the probability of a threshold, and get with certain numbers, and you can right. And it is sort of structured data, right? It's semi-structured data, so there could be ways to filter based on the record. Maybe no. So, but what is the graph? So, I mean, so far what I've been doing is just, it's just a document. I mean, it's vector search, but it's not vectors. I mean, it's just a similarity search engine, right? It's all LSI is, right? Reduced dimensionality search. So what is? I mean, I could see how vector search is just really another version of that. Better, maybe. I don't know. All similarity searches perform differently in reality. You know what I mean? Like they're just like different embeddings. Perform differently. And it's just a matter of experimenting which do the best. But what the graph approach? Yeah. Okay.
You have more control with graph, but less. It's like precision and recall. More precision, less recall, right?
Yeah. Makes sense. Okay. Any other thoughts? Oh, I know. Other thing is that Google GCP, they have, since we're GCP customer, and I've access. They use ANN. They have this application for approximate nearest neighbor vector search, or approximate nearest neighbor search that's scalable. Do you know anything about? I mean, is ANN particularly good in terms of similarity search, or is it just that it's scalable?
It's scalable, and different companies have different things. So I didn't know this, but the Elasticsearch ANN is per segment, so every time the segment shifts, your ANN results will shift, compared to Vespa, which is per index. So your index, you control whether it shifts, right? I mean, so in that sense, your ANN results don't shift until your index shifts, which is expected. At that point.
What do you mean? You mean like you re-index?
When you re-index or you distribute it differently, right? Whereas with segments, segments are created dynamically as and when needed. If your memory usage goes too much, it will just try to dump it into the disk, and then it will try to reallocate index. This is all done by Lucene. So you don't have any control over it. So since Elasticsearch has their implementation is per segment rather than per index, your ANN results will shift if this happens, like index merges happen or index splits happen.
And segments are basically splitting of your data already into some
splits and merges. Both, yeah. But these are all internal stuff. I pick these up like anecdotally, right? Because I'm in that relevant search Slack. So you have these guys talking back and forth. I just listen in. So that's how I know. So.
Yeah, I mean, that can matter a lot in certain circumstances.
Right,
You get different results each time you run it. But typically when you're doing similarity, you're not going to notice that.
Exactly.
Because similarity is so fuzzy to begin with, right?
Yeah.
So, okay. I mean, there's a huge advantage. I was just hoping that Google would have, a great, like basically a managed similarity service that I could just, use, try out, but they don't. The big thing at Google is they announced Vertex. See, it probably doesn't matter to you guys that much. VERTEX. And
yeah, Vertex.io. Yeah, that's right. Yeah.
Yeah, at Google I/O. Yeah, and I listened to that presentation. There was 2 of them, and I'm trying it out. And I've been on the call with our Google rep too. Brought in a specialist on it. I'm going to try to explore Vertex, see how that works and what it's good for.
Yeah, one of my co-authors will probably be writing a book on it. So.
Oh, okay.
Yeah.
That's quick. That's awesome.
Yeah, he works for Google also, so it's not like he has some insider information, I suspect. So
it's very clear this is a watershed moment for AI with Google to me, because their tools have been unusable to a large extent. I mean, like Kubeflow, I couldn't use that. It wasn't worth it. It was just too big for a one-man show, first of all, and just too complicated for anything but a large enterprise with lots of people doing stuff. So this is like, and then they have stuff all over the place. Vertex really is I can really see all of their AI and ML capabilities coalescing around Vertex now. So I think it's a big.
It looks very exciting. I mean, they have captured a very good market. I'm thinking, they have aimed at a very nice market slot, I think. Yeah.
Yep, and they, in a way, if you think about it's just like a lot of the data science platforms that are out there, almost end to end, except for this is fully embedded in the cloud. You know what I mean? It's like part of a whole cloud. It's cloud managed service version of that. And I'm just like, when that market matures, it's going to be really hard to beat it.
Right.
I mean, it's hard to say that with machine learning and data science because it's so varied. So who really knows? But yeah.
Well, I hope AWS comes out with something like that soon, because we're not going to move to Google because of concerns about them scraping our stuff. So that's the only downside.
That's interesting. So yeah, no. But I mean, AWS already has SageMaker.
Yes, it does, but nowhere like an end-to-end solution. And apparently the guy who's behind this whole project in Vertex
came from AWS.
He's from AWS, yeah.
I saw him. Yeah, I just looked him up today. Yeah. So this is he's been there for a couple of years now, Google, but this is fruition of a lot of his work to some extent, I would guess, or his guidance. So yeah.
So I suspect he tried and failed at Amazon.
Yeah, I think that's coming second to the market, as Microsoft will let you know. Can be very good, right? The whole history of that. Anyway, okay.
So,
all right.
So I didn't follow that. Like I saw that there was an announcement, but sadly I didn't even read it. It's just because I'm not somebody else is doing this now. So, but if I want to point somebody to the Vertex, what's the non-bullshit present? Is there a good presentation that's not so much marketing, but rather?
I'm starting. I just posted my Twitter account, and I'm starting as I learn just to post to there. And I just posted a couple things earlier today. I don't know if it's quite the level you want, but it's a very quick video intro and their documentation, and then a very quick. I also posted a very quick example that uses BigQuery, but not because it uses BigQuery, but it very quickly shows how you could do an ML project on Vertex.
Oh, cool! Thank you.
And Suji, you were going to say something?
No.
Is that book? Where's that book going to be published? How do I
Most
follow
likely
follow
PACT.
it? Okay. And is there any way to follow it now?
I think he's still trying to get it off the ground. He asked me if I was interested in co-authoring, and I said, I don't know anything about it. I'll be learning as I go, and if that is okay to him, and he hasn't replied. So I'm guessing it's not okay for him.
Oh, that's cool though. That's really interesting. All right, well, we'll see how that all evolves. Yuri, you saw my Twitter link there.
Yeah, I'm looking at it now.
Okay. A couple other quick things. Have you guys ever used WSL? Are you guys on Windows?
Not me.
You are, CG?
No, I'm not.
Oh, you've got a Mac.
Yes.
Okay. Yuri, are you Windows or?
I'm Windows and Linux.
Okay. So have you used Windows Subsystem for Linux?
No, not successfully. No. I think so I think it was updated recently.
Yes.
So I installed it on one of the computers, but it wasn't like an easy way to like use it. So I switched to doing dual boot.
Okay. So I just installed it's WSL2. Okay.
Mm-hmm.
It's finally kind of matured, and Debian. I'm using Debian, and my hope is because I'm using containers. So now my next step is to see if I can migrate containers and Docker into that, because it's driving me crazy to be working in Windows and to have to open up, containers from a Windows environment, and have two different command line commands to use, and it was screwing me up with DVC. So I'm trying to work in that direction. So, but if I get in there and get it working, I'll walk you through it if you need to.
Yeah, that would be interesting. So I really don't like dual boot Linux, mainly because it's Linux freezes on me, and there's like no way to easily fix it. And we are not we don't have IT department. We're on our own. So
it's really
hopefully if somebody has the same problem, then you're lucky. But
it's great because it's super lightweight. So basically, I can go into my normal command line interface, and I just type in Debian, and bam, I'm in the Debian command line. Okay, that's it. It's in Windows Subsystem for Linux. It's super lightweight. It's super easy to use. So dual boot's like 1970s now, dude. You're like 1980s.
So it's Debian is a Windows command that will take you into a Linux-like console?
Right. So what you do is you enable and install WSL, but then you just follow instructions to do that. But then what you do is you go to the App Store, the Windows, the Microsoft App Store, and you find the Linux distro you want to use. They have Ubuntu, they have everything there, and you just install it like it's an app, right? Which I've never done before with Microsoft, but you install the app. And then once it's installed, you can just use that command, or you can open it, the way from the icon for the app, and it'll open up that command line interface right there, with that distro. And then on your Windows command line, you can also use WSL commands, where you go WSL-L-V, so you could list your versions that are running, and you can see that your Debian WSL environment is up and running, and you can have multiple different Linux environments. But it happens. It's not like it's just all very seamless, and it doesn't seem like it's not like you have some virtual environment, or something you have to enter, and your machine grounds to a halt or anything like that. It's all very seamless and easy. So
okay, yeah, it's supposed to be, from what I've read, So, I recently got my second Mac in this company, right, after 5 years. So every 5 years, they give you a new one. I was actually looking at Windows and WSL as well. But I didn't get very good feedback from the guys who actually use that. So that's why I kind of backed off. Because once you get it, you cannot return it for 5 years or 3 years in case of Windows, right? I also did a Linux pilot while I was considering it. But they had issues, nothing to do with Linux, but mostly to do with our network's integration with Linux. There were various things that were just not supported properly. We use Office 365, which is a Microsoft product, but there is not enough, so we have also very restrictive access policies, which are not possible to do with Linux because they're not Microsoft. So there were the whole bunch of things, which kind of, I could not use it because the rest of my team is on Mac. So
when did you make that decision?
I think this is about 2-3 months old now.
Okay. And were you able to get it? What is it, an M1?
Which one?
The Mac, they now have the Mac for data, like with the GPU.
Oh no, I don't have a GPU. They don't give us GPUs. The thing is that basically they say we give you cloud access, go use GPUs out there.
Yeah, of course. I think it's GPU, but it's a newer processor that's much more powerful. You've heard of the M1 or something? People talk about it now.
Yeah. No, I haven't actually heard. I can tell you what my About the Mac says.
Yeah.
MacBook Pro 16-inch processor, i7, Intel Core i7. So it's not M1, I think. Yeah.
Yeah. Yeah, I mean, I'm not. I used to use a Mac when I was at the startup in Seattle. I got very used to it.
Yeah. My previous job we used Linux. Well, they gave us Windows boxes, and we could convert it to Linux if we wanted to, but IT won't support us after that because they didn't know how to. So we could do whatever we wanted there on that within the bounds of as long as we can connect to the network, you have root on that machine. So
so the only other so hopefully I'm moving towards that. The only other thing is I did watch a presentation on Anaconda projects, which is kind of interesting. So you guys don't use Anaconda, do you?
I do.
Oh, you do. Are you familiar with projects?
This is a new one. I watched the thing. It was this week, right? Sometime.
Yeah. Were you on that, or you watched that as well?
Yeah. I was on that.
The funny thing is it's like almost exactly the same as ML Flow projects, except for ML Flow projects are experiment oriented, but they all do the same thing, where you declare everything in YAML and then you have some sort of interface for when it's opened up, it'll install everything and open up a GUI or just depending on what you want to do, you can control that whole thing. It's kind of interesting. Are you going to use projects for anything?
Not sure. I mean, so I was thinking of it more as a replacement for Conda Activate multiple environments, and it seemed to be like it becomes like your project has its own environment. You basically give it its own environment, so every project can have its own little environment, which I think is a nice step. But yeah, I'm not sure yet. I mean, whether I want to go for it or not, but
isn't it mainly a sharing thing?
It is sharing, but we can get by with a lot of the things that we do. So homegrown bad practice, I guess. I don't use DVC, but in my project readmes, I basically point to the location in S3 where all my data resides. We don't shove data into GitHub. But we point to the data area, and you can basically do an S3 AWS S3 CP -R and get everything down exactly as and you can start, right? So those commands are there as well, so you can just use it. So yeah. Oh, also you started using requirements.txt. So anytime you have a project, you list out all the dependencies so people can build their environments.
But so not everyone uses Anaconda then, because if you did, you'd probably use YAML. Anaconda YAML.
Yes. No, everybody does not use Anaconda in our case. I use it, So, most of us use pipenv. That is, standard in engineering at least. And they use pipenv and virtualenv, right, with that. So, but requirements.txt is nice. You can just do pip minus requirements.txt,
Yeah. Well, it used to be. I mean, the reason I started using Anaconda originally because you used to have to compile stuff and build stuff, and it was not easy, like with scikit-learn, right? And that's when Anaconda really took off. Yeah. But now there's not so much of that because of wheels, I think.
Right, exactly.
Yeah, so I think that I'm not even sure the advantage of Anaconda these days.
Yeah, Anaconda, and most likely the way I'm using it is illegal because, they have started saying that you have to pay us if you are a company over a certain size. If you work for a company over a certain size and you use it for work. So I'm just using it. I'm stuck to it, kind of.
Yeah, me too. Okay, yeah. I mean, one of the advantages of just using I saw when Cheng did this if you use just virtual environments instead of Anaconda, you can actually very easily make those kernels in Jupyter. Whereas with Anaconda, that's harder to do, I think. And with containers, it's almost impossible.
Okay.
But yeah.
Anyway. I used to have problems creating Jupyter environments. Like I had to create it manually with IPyKernel. But nowadays, the latest one that I'm using, it creates, automatically creates every time I create an environment, it creates a Jupyter kernel with it. So, lately I've been seeing like any Jupyter notebooks I open in my different, inside my different environments, there is automatically an entry for me to open it in that particular thing.
Because it's picking up on the Anaconda environment?
I think so, yeah.
You probably have a plugin. It's probably a plugin.
Could be a plugin, yeah.
Okay. All right. Enough engineering talk. Does anyone have anything else they want to talk about? Yuri, you got any updates for us or something you want to talk about?
I just wanted to say, so we did kind of a very high-level review of the mapping project. And as I was preparing for it, I looked at on SBIRD website some more. And I realized that they actually keep so I saw the papers recently, but they actually kind of implementing software, and they actually implement other people's papers also. So there was a paper recently on using contrast extension to do similarity, and they re-implemented it into their system. So I was thinking of maybe trying that at some point if I think I can, I can have, data for, if I find like a good data for that. And they also basically point to how to integrate their vectors with Elasticsearch right in the documentation now. And the other thing is they basically also implement ANN. They have their own implementation of ANN on top of their own vectors. That's how I understood it. Because no, the sentence transformers.
Oh, I see. Okay.
That's better. Because I always knew that they could do like a really fast search in vector space, but I think now they actually say it's ANN.
Okay.
But I haven't looked into it. I was just like, I looked at the website and the documentation is much longer because they added all this stuff. So it's pretty interesting that they basically building software for a tool out of their research.
Yeah, SBIRD is on my queue of things. I'm trying to get to the Hofstadter lectures, and hopefully they'll cover a bit of that. So then I'll start looking.
I think
get some back.
The way I don't know how they're connected. I think like I saw those lectures from the tweet from one of the guys who work on SBIRD.
Okay.
So maybe I don't know if they like worked together before or. Yeah.
Who's behind SBIRD? What's the organization?
It's a group in Germany, Ubiquitous Knowledge Group or something.
Are they a private company?
No, it's a university.
Oh, university. Okay. Yeah. That's a good place for my similarity problems, except for this, it's I'm using long documents, which is always a problem. Or, you know. Anyway. All right, guys, we got anything else? Or is that it for today?
I think that's it for me.
Anything else, Yuri?
Oh, no.
All right. Well, we'll talk next week. Thanks.
All right.
Talk to you all soon.
Thank you.
Sure. All right.
Good week. Bye.
Bye.